Hi, my name is Vahan Davoudian. I'm a physics experimentalist for 33 years. I'm so grateful for your emails, for your comments, and then everything else. That was so encouraging. Thanks a lot. And today's topic is so important, it's extremely important because imagine we are dealing with the planet. So I'll give you one example. Helium is the second most abundant element in the universe after the hydrogen. In 1868, the French scientist Janssen discovered that in sun spectrum we can find helium. It took another few years, and then when they discovered helium on Earth. And in fact, it is so important that today we are talking about the mass spectrometry because this is the way we can analyze the soil, atmosphere, temperature, and we can even go to Mars and beyond. It's so important. So I will explain step by step. It's not very difficult. Well, I simplified everything. And let me start with this now. So it's mass spectrometer, and this by Vahan Davoudian, physics experimentalist, and this is my email, vahandavoudian1948@gmail.com. This is amazing device. In science, I would say this is the most important device is ever been, invented. Well, of course, always, mass spectrometry works with the, light spectrometry because if you remember, in June 16, 2024, I had the spectroscopy, and that was analyzing the light. And imagine how important it is. Without even traveling to the planets, you can find out their composition, you can find out, what they're made of, and then you can find out their temperature, you can find out their atmosphere, and everything else. And then when we go to that places like in Mars, and then you have a lot of information. So this was invented by, mass spectrometry was invented by, invented by Wilhelm Wien and J.J. Thomson. Well, of course, you guys remember J.J. Thomson. He was amazing scientist. He was the one who discovered the electrons, and then he was the one who helped. And in fact, I remember when I was so young, I remember how could we get the atomic mass and things like that. And then he was so genius. He discovered by the deflection of the electron beam in the in a tube, he could find out mass to charge. Anyway, this is the way he did. But this is mass spectrometry. I will explain in a little bit. And imagine, this is so important. You can have like a soil, you can have like a rock or everything else, and then you can analyze their composition. And well, of course, there's much more. I will explain in a little bit. And this is amazing photos. I had to get this. And this is in 1997. This is called Christian Huygens, mass spectrometry. Well, of course, it doesn't show everything, and you can see this is the Saturn. And then this was amazing. It analyzed everything with a great precision in 1997 for the atmosphere of the, like Saturn and everything else. And in fact, this is the basics of the mass spectrometry. And it's exactly like the way we did it on light. If we want to have something, any gas or anything, we have to heat that gas, then we have to get a spectrum. And then if you remember, I explained 6-7 months ago, June 16, 2024 for the spectroscopy, we have like a special fingerprint. They call it, spectral lines. So they have like, light and dark lines, and each element amazing in nature comes with the special dark lines and bright lines. They call it the spectral lines, and in fact it's like a fingerprint. That is the way we discover so many elements. And this is the way the mass spectrometry works. Well, of course, this is not everything, but it explains the basics. And this is the sample, and the sample is heated, and then we have accelerators here, and then they accelerate through this, then they go to millions of megavolts, so they go here, then we have a magnetic field here. And amazing, if we have in a soil 3 or 4 different elements, and some of them iron has so many isotopes. This is so amazing. This device can distinguish between low isotope and the high isotope. And imagine this one, the red one, you can see deflected less because it has less isotope. This one is deflected more, and then, well, of course, this deflecting is converted to electrical signal. Then we can see here, and in fact, this is so important. I'm hoping maybe it's not going to be my lifetime when we travel to Mars. This is the only way. Well, of course, we have sent to Mars so many rovers, and then, they analyze the soil and everything else. We almost know maybe 50% about the Mars, but, this will help us, to go beyond Mars. But, I'm hoping that, you guys just listen carefully that how important this mass spectrometry is. I have another one. Let me take this down. This is the picture. A few minutes ago, I mentioned for the light spectroscopy, and in fact, this light spectroscopy or mass spectroscopy, they work together. This is the one I explained a few months ago, but I have to just refresh your mind. See. This is the sun, and then you can see we have the photosphere, we have the core, and then these are the spectrum, and then you can see these bright lines here. This is from the chromosphere, but this one, the dark lines from the photosphere. And these are exactly, each element has unique lines like this. Well, of course, this is a block diagram, and then I will explain a little bit. And then we have the sun over here, and then we have the mirror over here, and we have the grating. And grating means that, is splitting everything. So sometimes, this grating is much better than prism. And then this is another reflected in here, another mirror. And now we have, bright lines, and then we have the dark lines, like, magnesium, sodium, and hydrogen, and everything else. And this helped astronomer a lot. I mean, so important. And we can see the elements by, distinguishing their lines, bright lines and dark lines. Well, of course, this is a picture showing, this has like a special scoop, scooping the soil, and then analyzing everything right there, and you don't even have to have any astronaut on board, and we get lucky if they function properly, they can send all this information to us. This is another one, and it's showing that they're doing like rocks and then soil and everything else. Well, of course, mass spectroscopy has so many applications, because it's so versatile, so indispensable. It is used in every aspect in a science. Let me put this up, you can tell. Well, of course, I had to get some of them, not all of them, but you can see how important this mass spectroscopy is. And I'm hoping one day if we, colonize Mars, this is a great help. This is the only way we can colonize different planets, because you don't have to even travel. I mean, how amazing it is, 1.5 million kilometers to sun, and then it was on Earth already. I mean, helium was there here, but we didn't know. But that, genius, he discovered the helium is in sun, and that was great discovery. And after that, we had so many other things they discovered. And imagine Marie Curie, when that great scientist, when they got radium and polonium, there was no way they could tell what they are. So they had to call another physicist. Then they analyzed the light and then the spectrum, and they knew that that was a polonium, that was a radium. And like I said few minutes ago, it depends on, well, I have to explain a little bit about the, sometimes we have, like carbon. We have sometimes we have like different elements. They have, exactly the same number of protons, but their neutrons are a little bit more or less. So that's why we call them isotope. In fact, the atomic number is not changing. What is changing is the mass. And this device is so good, it is showing if you have like 4 different isotope in one, soil, it can exactly tell you this is that, this, and like that. And these are the ones, for the, application. Like I said, it's a space exploration, and, there is no way that the human being another 100 years is going to be in this planet, because we have like asteroid, we have like so many disasters. They might be able to, go to the, Mars and the beyond. So space exploration, and then drug discovery, identifying compounds, impurities. Sometimes, when you are checking something, you have to see what the impurities are. And then the food contamination detection, that is another important aspect. And then environmental analysis, detecting the pollutant, because we have no idea how bad our air is. So this is detecting everything. And protein identification, isotope ratio determination, which I explained to you, and pesticide residue analysis, and clinical diagnostic. Colonizing Mars and exoplanets. We have, God knows, maybe 800, 900 exoplanets, but they're far beyond our reach. But, it's not bad. I mean, I always agree that, we can analyze their soil, if we can send a, rover, or, their temperature and everything else. By analyzing atmosphere, temperature, soil, and rocks on Mars, we can go back in time. And imagine, I have seen so many science movies that, Mars was like Earth, but unfortunately, that was exactly the same soil and everything else. But unfortunately, after so many, maybe billion years, they lost their magnetic field, and then the atmosphere and everything else. But, still, the humans wants to, travel to Mars, because that is the closest so far, because we cannot go to Mercury or the Venus or the others, and we are already on Earth, and this is the only option for the time being, I think. So, and this is extremely important, that you maybe realize how important the space probes are. Imagine we don't have microscope. We didn't have space station, International Space Station. International Space Station is like a planet. That is the most important planet in our life. It's only 400 miles, but imagine so many scientists did breakthrough science. And I remember his name was Don Petit. It was 2003, and then he was doing some experiment with that was I think salt grains, and then he realized in microgravity they clump together. This was a mystery for many years for the astronomers and physicists, how the planets are forming. And then this discovery was amazing, what Don Petit, and then we realized that, this is the way in microgravity, everything, those little pebbles, electrostatic charges come together, and when they get like half a mile in size, and then the gravity takes over. And in fact, always I remember, in my theory, as I mentioned, that the gravity is just charges. Well, of course, I do agree with Albert Einstein what space and time, but practically it's the charges. So this is the way it is, and then we can see how important the spectrometry is. And next time you see the mass spectrometer, you can see how important it is, and then physicists can see what is the composition of everything else. Thank you very much for watching. If you like this video, you can go ahead and subscribe, and then I always love your encouragement. Thank you for watching. Thanks a lot. Bye-bye.